Consider the function defined by f of x equals this, where x is the all real numbers and x not equal to k. K squared not equal to 5. State the equation of vertical asymptote on the graph of y equals f of x. For rational function, y equals ax plus b over cx plus d. We know for the domain, we will set up cx plus d not equal to 0. We figured out x not equal to negative d over c. For range, y not equal to, look at the coefficient of x. You will get a over c. So y is not equal to a over c. And from this domain, you will figure out a vertical asymptote line. That is x equals negative d over c. From range, we will figure out a horizontal asymptote line. Y equals a over c. For a, we are given the function f of x equals kx minus 5, x minus k. So for vertical asymptote line, we will set up denominator equals 0. Then x equals k. Look at the b. State the equation of a horizontal asymptote line. Horizontal asymptote line will be y equals. Check the coefficient of x. This is a k. This is a 1. For horizontal asymptote line will be k over 1 equals k. Y equals k is a horizontal asymptote line. For C, use an algebraic method to determine whether f is a self-inverse function. You can use a definition. Figure out the inverse equals kx minus 5 over x minus k. Or you can work on f of x equals x. I will show you both ways to prove whether f function is a self-inverse or not. Work out this inverse function equals kx minus 5 over x minus k. To prove this function is a self-inverse function or not. Remember this escape button. Exchange x, y. Solve for y. Then change y into inverse f of x. First step, you will get x equals ky minus 5, y minus k. Then cross multiply to solve for y. We will cross multiply. X times y minus k equals ky minus 5. Distributive property, xy minus xk equals ky minus 5. Remember, we solve for y, and this is a linear equation. So cross to the left side. This one cross to the right side. You will get xy minus ky equals xk minus 5. Then common factor this y, x minus k here, xk minus 5. Then divided by x minus k both sides. You will get y equals Denominator is x minus k. Look at the top, I write down kx minus 5. Then last step, you will change y into inverse symbol. Then you can draw a conclusion. So f is a self-inverse function. Now let me use f of x equals x to prove f is a self-inverse function this time. So we have f of x equals f of kx minus 5, x minus k. This means every single x in the f function, you will change into kx minus 5 over x minus k. So we have k times kx minus 5 x minus k minus 5. Kx minus 5 x minus k, then minus k. First step, we need to get rid of this denominator. So we multiply x minus k for every single term. Therefore, this is a distributive property. You will get k squared x minus 5k. Distributive property minus 5x plus 5k. For the denominator, you will have kx minus 5. Distributive property minus kx plus k squared. Then combine like terms. You will get k squared x minus 5x. Cancel. You will get k squared minus 5. Common factor is x, k squared minus 5. K squared minus 5. Then this time, you can reduce. You will get x. So f is a self-inverse function.